In this video, I'm going to use the Triangle Sum Theorem, or sometimes called the Triangle Sum Conjecture, whatever, same idea. I'm going to use that to solve some basic geometry problems. The idea of the Triangle Sum Conjecture is pretty simple, pretty straightforward. If I add together the degrees, the measures of the three interior angles of a triangle, they should add up to 180 degrees, always, every single time, no matter what the shape of the triangle, whether it's acute or obtuse or scalene or isosceles, I do not care. So here are some simple problems that we can do now. If I know that the three angles on the inside add up to 180 degrees, I just need to write this as a mathematical statement. So in this case, I have angle x, 2x, and 3x. And what I know is that if I sum x and 2x and 3x, they should add up to 180 degrees. So now it's just a job of combining like terms. I have a total of 1, 2, 3, 4, 5, 6 x's over on the left. Those 6 x's add up to 180 degrees. And if I divide both sides by 6, 6x is 180, so each x individually should be 30. I now know that this is 30 degrees, and I could also go back if I wanted to and tell you what each angle is. That means that this angle here must be 30. This is twice as big as 30, so 60. And this is 3 times as big as 30, which would be 90 degrees. So I can tell you not only what x is, but I can tell you each individual angle. Here's a second problem. A little bit different. I have a square here. That means that is a 90-degree angle. And that means that 90 degrees out of the 180 has already been used up. That means A and B must be splitting the other 90 degrees, right? So I know then that A and B add up to the other 90. And now I'm going to substitute in this given information here. The measure of angle A, that's what M stands for, the measure of angle A is 3x plus 10. And the measure of angle B is 11x minus 10 all over 2. And if I add those two values up, apparently they should add up to 90 degrees, the other 90 that's not part of this right angle. So now this one's a little bit more complicated, probably a little bit scarier just because it involves a fraction. But I'll tell you this, the easiest way to get rid of fractions is to multiply every single term in the equation, in this, by the common denominator. In this case, this is just 2, right? Would be the common denominator. So if I take this and I multiply this piece here by 2, and if I multiply this piece here by 2, and if I multiply the piece on the right by 2, I multiply every single thing by 2, the fractions go away. See if I can zoom in here a little bit. Okay? So here's what it looks like. This looks like distributive property to me. So I'm going to take the 2 and distribute it out to the 3x and the 10. That gives me 6x plus 20. Now, the magic part happens. I shouldn't call it magic, it's just math. But the cool part happens now that I've multiplied this by 2. If I'm going to take this 11x minus 10 piece, whatever that numerator is, I'm going to cut it in half and then double it. I'm right back to where I started, right? So why cut in half something if you're just going to double it? Those go away. I'm left with only the 11x minus 10. That's why I multiplied every piece by 2. I can't forget, though, that I need to multiply the piece on the right by 2 as well. Now that's at 180. And here's something that looks not too bad, right? I'm going to combine like terms. 6x's and 11x's add up to 17x's. 20 minus 10 is 10. Those two add up to 180. Let's subtract the 10 away from both sides. If I subtract 10 from both sides, that goes away. This goes to 170. X must be 10, right? Divide 17 out. So now I know, depending on what I wanted to solve for, if I was asked to solve for x, there's my answer. I now know that I can go back over here, and if I know that a is 3x plus 10, that's 3 times 10, which is 30, plus another 10, which is up to 40. This must be a 40-degree angle, which means that this one here better be the other 50 that was remaining out of the 90, right? I can check that if I want to. 11 times 10 is 110. Subtract 10, I'm down to 100. Cut that in half, and that's 50. Everything works out, doesn't it? All right, here we go. Third example. Sometimes they don't even give you a picture. They just say the interior angles follow this 3 to 6 to 10 ratio. Well, the easiest way to do this, I'm just going to draw a quick triangle so I have something to look at least. When you're talking ratios, what they mean is this. Okay, the triangle's not drawn to scale. I'll just let you know that. I'm not a very good artist. That I can put in this for the three relationships. They have a 3 to 6 to 10 ratio, means I don't know what like the smallest increment, 3 times as big as what? I don't know. 6 times as big as what? I don't know. 10 times bigger than what? I don't know. But I know that this is 3 times, 6 times, and 10 times as big as some number. So now you can see I can take these three ideas, I can put them together and say they add up to 180. That would be a grand total of 10 and 6, 3, that's 19, right? 19 x's. These 19 x's add up to 180. 3x plus 6x plus 10x, right there. I skipped a step, didn't I? But now I can go through and I can divide this out. Gives us kind of a messy problem here. I don't know why I picked 19 there. That was dumb. But if I get 180 over 19, that was really stupid, by the way. I should, you know what? In fact, here, watch this. We'll make that a 5. Okay, good deal.
Jeremy Hayes, call extension 4118. Jeremy Hayes, 4118.
All right. Sorry I had to deal with that. Hey, looky there. 3 and 5 and 8, those add up to 18. That's a nice, convenient number, isn't it? Those 18 x's, now that I changed the problem, add up to 180. That means each x was 10. So now I know that the three angles are 30, 50, and 100. So depending on what we're trying to solve for there, what our question is asking, we know everything we need to know about the triangle. Last problem. Ooh, this one looks difficult, doesn't it? Solve for x. Holy cow, what do I do in a problem like this? Well, it turns out that if I just ignore part of the problem, let's say I ignore this, and I just look at this angle, don't I know that these two angles put together add up to 180 degrees? So if 140 is spoken for, I know that the inside here is 40 degrees, the other 40. So I'm going to go ahead, it just takes an extra step, but I'm going to say that's 40 degrees. Now, the three angles add up to 180, right? So if I have 120 and 140 here, that's 160 that's already spoken for. Or I could write it this way. The 120 degree angle and the 40 degree angle and x add up to 180. Well, that's pretty simple then, right? It's 160 plus x is equal to 180. You know what? I'm going to subtract x, or 160 from both sides. X must be 20 degrees, right? So there's 4 basic problems. Those are pretty typical of what you're going to see in your homework and on any kind of math test involving the triangle sum conjecture or the triangle sum theorem.